With that, we're going to bring out our first panelist. The first panel features Nathan Michael. He's the CTO of ShieldAI, the leading US-based defense technology company that specializes in artificial intelligence-powered systems for military applications. This panel was moderated by a former TechCrunch colleague of mine, Darrell Etherington, who is now the head of network at OMERS Ventures out of Toronto, Canada. Give him a round of applause and bring him on out.
All right, thank you. And thanks for joining us, Nathan. Great to chat with you this morning. I want to start things out. We had a lovely story about this building and like kind of how it factored into military history. And it was home of a transition from crossbows, bows and arrows, into gunpowder, which was kind of a reluctant transition, according to the story, but then became kind of the default, right, for modern warfare. Are we at that point now with AI? Like, it really seems like there are a lot of autonomous systems in development. Is that going to become the new default for kind of the warfighting domain?
Yes, it absolutely is. I think that the greatest challenge to adopting a new technology is both understanding the technology as well as being able to verify and validate that technology. Mm-hmm. And within the context of autonomy and robotics more broadly and AI, we grow more and more aware of how to do just that through both testing and evaluation of the technology, as well as through just theory and practice being able to show evidence of what we can expect to happen and that it will perform as expected.
Right. I think, yeah, that seems to be one of the overall kind of worries. And, you know, I think they're not of a piece. Like, we talk often in the consumer sphere about Gen AI and sort of like chatbots, right? But the unpredictability is an element that everybody kind of has anxiety around. And obviously, there's no world in which that would be more dangerous than kind of the war-fighting world. Right?
Absolutely. I mean, more broadly, AI as a means for decision-making is something that one has to be very aware of what the technology can and is able to do versus cannot do, and where human and operators must be included on the loop to make those decisions. And so for us, the way we approach it is we think very carefully about what part of the overall intelligence that's running on board each platform and within the system, and how best to apply AI, machine learning, to ensure that the highest levels of performance while also ensuring that the decisions that are made are those that one would expect, that are trustworthy and within the expected parameters of operation.
Right. And so just to ground this more in what you specifically are doing, can you take us through kind of, especially HiveMind, and like what that is and how it's being used today, or how you're thinking about deploying?
Sure. So HiveMind is just the term we use to describe our AI and autonomy framework. It incorporates many different parts to it. It is that edge-level intelligence that's running on board platforms, and this is where then you're going to have single individual platforms engaging intelligently, able to think for themselves, drawing the operator in and on the loop where appropriate, but also able to operate without any human engagement at all, depending on availability of external information, communications. And then in addition to that, we have a fairly substantial ecosystem that's oriented toward being able to build those pilots, to be able to validate and verify the performance of them under a very large set of scenarios and conditions. And so you could think of that as sort of like a autonomy factory. And so the combination of that factory and that edge-level intelligence, that pilot, is really what we leverage within the context of HiveMind. There are some additional components related to how to integrate it into a broader ecosystem, to draw in data and to be able to provide data to other external systems. But at the heart of it, that is what HiveMind is. And then in terms of how we use it, we've applied it now and taken through to the point of flight testing, evaluation, and operationalizing capabilities on 6 platforms, moving from smaller quadcopters all the way to more of a kind of group 3, medium-sized system, even to larger platforms. So think of that as uncrewed jets and similar. We leverage it within an operational context more on the smaller scale systems at this point. And we have deployed those systems in scenarios where there is no prior information. The systems must be able to start, perceive the environment around them, operate within that environment, make decisions, leverage the opportunity to talk to operators when it becomes available, and ultimately progress toward the mission regardless of the conditions. And so that's where you're entering a domain where no one has been before, no one knows anything about it, and so the system has to be able to truly think for itself to be able to succeed within that context.
And that what you're seeing there is like you're essentially taking like a sort of platform agnostic approach, right? Like you want to be on whatever hardware is available, which I think is interesting in the context of yesterday we heard a lot about software-defined warfare and also how a lot of the forces out there are like they want to use their legacy equipment, right? They want to use the existing expense. So was that always the goal for you, was to be able to work with the equipment that's already available?
That has always been the goal. So our objective is really at the heart of it, proliferation, and the ability to deploy resilient intelligence to as many systems as possible. When we started driving toward the vision of HiveMind and building out the 1,000 building blocks that it took to bring that together, we focused on the key fact that we need exquisite performance and behaviors from an intelligence perspective, but that exquisite performance and behavior will need to be exhibited on many different classes of platforms. So we focused on this sort of 90-10 model where there is 90% commonality across the domains and across the platforms that you're performing on. And what you really want to focus in then on is the specialization, that last 10%. So we created that factory with the intent of being able to truly apply those capabilities very efficiently and effectively so that there is not a one-size-fits-all generalized solution,
right,
but we have the ability to create extremely high-performance specialized solutions very, very quickly. And so what we saw was early on, several years ago, it took us, let's say, about 40 months to build this intelligence that allows the system to truly operate and think for itself, as I was describing a bit ago, to now we approach a new platform, and it takes us about 3 months to get to a similar state, or roughly that similar state. And again, that's because the autonomy development lifecycle and what's required to really achieve that can be made or rendered kind of common. And then you can really focus on making that as efficient and performant as possible to allow you to then spend the majority of your time on that specialization.
That's an amazing delta, like the 40 to 3. Do you see it getting even more efficient?
Oh,
or?
yeah.
Oh,
yeah.
Wow.
I mean, we are integrating more and more advanced techniques. Everybody, of course, is familiar with LLMs.
Yep.
Everybody is probably, well, you can use a number of different techniques to do everything from auto-generate scenarios and trials and test at scale in a variety of different environments, auto-generate code. You can use those types of technologies to actually automate certifiability and to generate all the artifacts that you need so that you have confidence in the platforms and what they're going to do. Ultimately, the objective, which is not where we're at, but where we'll be in 18 to 24 months, is that a non-subject matter expert can walk up to the system and say what you want the system to be able to do, and have all of the supporting documentation you need to have confidence that it will do what you have asked it to do.
Wow.
And that's the big delta, is the difference between highly expert individuals, engineers, developing these capabilities, and automating and leveraging recent technologies to be able to make it so that a broader audience is able to achieve the same types of outcomes, but have that supporting evidence to know with confidence that it will actually do what they expect. So what used to take 18 months, ideally will be brought down to 18 minutes.
But not only that, then also decrease that talent requirement, that specialization requirement.
Absolutely. And we're even seeing that within Shield itself. So we have this product, and then we have a team that applies the product. And the team that applies the product, when we execute these projects to put it onto different platforms, we need about half the people we needed a year ago or 2 years ago.
Wow.
And where in the early days we needed PhD and master students, often individuals that in my prior life in academia studied under me within an academic context, now we have undergrads and master students able to achieve similar outcomes in a very short period of time, adding value and on-ramping within days of joining the company.
Wow, impressive. Is there a flip side to that, though, whereby a lot of what you want from those people is also the rigor and responsibility, right? Like, do you see a gap there on the other side if you have less experienced people, or does that just change the approach we take when training these individuals?
Well, the strategy is to build the capability to ensure that rigor and that performance and that quality assurance within the factory itself. And so by doing that, you have sort of these guardrails that not only accelerate you, but keep you within the bounds as you're developing these capabilities, so that even if you don't realize that what you're doing is necessarily a problem, there is a whole layer of intelligence assessing what you're doing and providing commentary feedback and giving you that information very, very quickly. And so by doing that now, you don't have to have the same level of expert training to know what right looks like, because you have technologies supporting you in that development.
Cool. Just a quick question on kind of like competitors and the landscape overall. Is this the kind of market you think where it's a winner-takes-all sort of solution? I mean, there's obviously going to be redundancy. People don't want, armed forces don't want like single-source providers, right? But is it a winner-takes-most scenario? And how do you think about, is Anduril a competitor, for instance? Are they a potential partner? Like, what do you think generally about the landscape there?
So it's great that the landscape itself is expanding, obviously for the mission and for diversity and to ensure that we have the best of breed, if you will, of outcomes. In terms of the actual outcome of will it be winner takes all, I don't think it can be. I think that there has to be a sovereign capacity that all want to have to be able to accelerate and deploy the greatest capabilities possible without a huge or significant reliance or vendor lock-in, if you will. Right. We've specifically designed our capabilities to that end with that intent in mind, that it allows sovereign capacity to be able to add your own IP, own your own IP, be able to deploy, iterate, develop with the same velocity without requiring ShieldAI to be part of that process. And so we're at the point now where we're actually working with third parties, so other companies. We're working with other countries where they want to be able to build the same type of and proliferate the same type of resilient intelligence, and they want to be able to do it with the same level of velocity without necessarily demanding the same expertise pool. And so we are looking to enable that because ultimately, if our objective is proliferation, having many different entities helping us to achieve that outcome is a great force multiplier.
Great. So we only have about a minute here left, but I'm so curious about, you know, right now you're in air vehicles, right? Air combat. Is that the vision overall, or do you foresee this technology being applicable in sort of like all domains?
It is applicable in all domains, but we have to earn our seat at the table for each domain. And so we have focused in the air domain, but more broadly, the autonomy development lifecycle is one that's applicable from air to maritime to ground and surface, even to space. And I have, in a past life within academia, worked in all of those areas except for space. And I can say, having deployed systems or developed systems to that end, that it looks like the same motion, but it's in that specialization where things start to differ.
Right.
But that framework and that common foundation is certainly something that is applicable across domains, and we're certainly starting to move in that broadening perspective. But really, this is an area where evidence and outcomes matter first and foremost, and so we want to make sure that we can substantiate those kinds of remarks.
Great, amazing. Well, that's our time, but thank you so much for joining us, Nathan.
Fantastic. Thank you.